Hi, so today I will explain to you the manual calculation for question number 1. So first we need to find the value of m by using the equation of y equals to mx plus c. So we can find the coordinate value we can refer the figures given to find the coordinate value. So in our groups, we are using the value of frequency, which is 49.9 kilohertz, and we can find the value of t by using the equation of 1 over frequency. So do the mathematicals, our t is equal to 20 microsecond. So next, we need to find we need to find the Fourier series expansion for the signal xt. But first, we need to find the a naught value. So by using this equation, we can get the value of a naught, which is equals to 3 over 2. Next, we need to find the value of an by using this equation with cost, and simply do the mathematicals by applying the value that we already have. For example, like t equals to 20 microsecond, and it will be equals to 100 kilohertz. And when we do the mathematicals, finally we will get the value for even and odd. So after we do the calculation, our even value is equal to 0, and odd value equals to -2 over n power of 2 and pi of power of 2. After that, we need to find the value of Bn by using the same equation as An, but we need to change cos into sine. And still the same, we just apply the value that we already have. For example, t equals to 20 microsecond, and simply do the mathematicals. We will get the value for even and odd. So for Bn, even is equal to -1 over n pi, and odd equals to 1 over n pi. And finally, we can calculate the value for xt by plus minus the equation of an and bn. And finally, we can get this equation. We will get this equation for xt equation. And finally, we will get this equation for xt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amirul Farhan bin Baharudin. My matrix number is DE20001. So for today, I want to present for the question 1. So as we know, we use the frequency is 49.9 kilohertz for the frequency, and for the resistor we use the 600. So this is the for the coding for question 1. So as you can see from the line 10 until line 17, this is for the 5 harmonics. So the first graph, the first line for the formula, and for the title I put the time domain for 5 harmonics, and for the x label I put the time, and for the y label I put the amplitude. So this is the time versus amplitude. So in the line 19 until 26, this is for the 10 harmonics. So it's the same, and for the title, time domain for 10 harmonics, and for the x level time and the y level amplitude. So same, time versus amplitude, and then this is the 20 harmonics. So just same, for in 5 and 10 harmonics. So I just run. So this is the graph that we get. So this line for the time domain, and for the this line is the frequency domain. So this for 5 harmonics, and this is for 10 harmonics, and this is for 20 harmonics. So that's it. Thank you. Assalamualaikum warahmatullahi wabarakatuh. And my name is Nur Amirul Farhan bin Baharudin, and my matrix number is DE 20001. So I from section 5. So we require to use the frequency 14 until 49.9. So my team, my member is decide to use the 49.9 kilohertz, and our lecturer name is Dr. John Xialing. So for the resistor, we use the 600, and then we must find for the C for the capacitor, and then we use the formula and put the value that we already have. So 1 divided to 2 pi multiply by 600 and multiply by 49.9, and then multiply for 4. So because this 4 times, so and then we get the capacitor is 1.33 nanofarad. So I pass the next present. Thank you.
Okay, Assalamualaikum and a very good evening to Dr. John. So my name is Muhammad Shazal Mafiz, and my matric number is CE210135. So I will be presenting my group 3 by doing a question 2 simulation using MATLAB. So I will show you to obtain it by using the formula of 1 over 2 pi RC. So we know our value for that is 2 pi over 600 column, and our C value is 1.33 nano. So we know. So we get the answer, okay, over 2 pi. So we will obtain a value 199.44 K. So this is by using the frequency cutoff formula. So there is one more by using this type of formula, by using directly 9.9 kilohertz times 4. 9.4. So we will obtain 199.6 K hertz. So we using this formula. using this answer in our simulation. So using this, so for our RS value 600 for the resistor, and for the capacitor we're using 1.33 nanofarad. For the frequency we use for 9.9 kilohertz, and for the cutoff we're using the formula that I just mentioned before, 199.6 kilohertz. So I will run this simulation, and as you can see, our result, our graph will be show that it's the same as the question one, like this: 1, 0.7, 0.5, same as in the question. 0.7, 0.5. So this is our low pass filter frequency response for the first order. First order. So by comparing our manual calculation, calculation and the simulation, we can conclude that it will produce the same as the question one, as the frequency response curve need, but for the simple low pass filter first order. So I think that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amirul Farhan bin Baharudin. So my matrix number is DE20001. So today I want to present for the task 3. So the task 3 we required to do the frequency domain and the time domain. So for the frequency domain and the time domain we must compare. So for the fs we use the 199.600, and then for the frequency for session 5 we use 49900. So and then we run. So this is the graph that we get for the frequency domain, and then for the time domain also same, we use the frequency is 49900, and then for the resistor we use 600. So for the graph we get the graph for the time domain is like this for the graph for the time domain. So that's it. Thank you.